Hello my dear students, welcome to the MS Science Academy. Myself Meenu Srivastav, and today we are going to discuss about the reactions of benzene. Before starting the reaction of benzene, first we have to conclude then what is the exact reaction of the benzene takes place. That is the electrophilic substitution. As we have studied that the aromatic compound generally shows the electrophilic substitution reaction. So if but one question it is in your mind, then why the aromatic compounds not going to the addition reactions? The answer is that if they are going towards the addition reaction, their aromatic character will fall off. Yani ki if suppose that if they are just going towards the addition reaction, so their aromatic characters just spoil. So that's why they are choosing the substitution reactions, and generally they are choosing the electrophilic substitution in 99% cases. Okay, so today we are going to discuss about the general mechanism of the electrophilic substitution, and afterwards we will discuss about the next reactions, other reactions means named reactions like the sulphonation, nitration, Friedel-Crafts, alkylation and acylation, like that. So first we have to study about the general mechanism of the electrophilic substitution reaction. Okay, so here now the electrophilic substitution. Okay, so as the name suggests, the substitution is going for the electrophile, and as the name suggests, the electrophile means the electron-loving species. Obviously, if the species is the electron-loving, that means it has the positive charge. That's why it needs the negative charge, or it desires the negative charge. Here, in the first step, the step 1, the generation of electrophile takes place. In the step 1, first step is that generation of electrophile. Here, the electrophile is generated with the help of acid, Lewis acid, if suppose that, or sometimes it will spontaneously generated. Okay, so here the electrophile generated first either spontaneous, okay, or acid catalyzed generation. Okay, so here the electrophile, obviously it will attached, generally it is attached with the nucleophile, and this electrophile is dissociated with the nucleophile. Okay, this is the spontaneous generation. Okay, but suppose that if it's the acid catalyzed reactions, the electrophile with the nucleophile compound, Lewis acid, generally the Lewis acid, I am just returning here the acid or representing as A, this acid will generally Lewis acid. Okay, here the electrophile, nucleophile and the acid complex will formed, in which the nucleophile is the positive charge and here the acid is the negative charge. So this is the less stable complex, because the nucleophile is having the positive charge, which is a quite unstable condition. So in this step, the electrophile dissociate with this compound and acid and nucleophile compound will form, and so this nucleophile generation is known as the acid catalyzed generation. Okay, so this is the nucleophile generation takes place. In the second step, the formation of sigma complex. Why the formation of sigma complex is formed? As this electrophile attack on the benzene ring, and it will just attach with the benzene ring and form a sigma complex. Why it's named so, we will discuss. Okay, so here in the step 2, formation of sigma complex. Okay, here what will happen? The benzene ring and the electrophile is attached. Okay, this is the benzene ring and the electrophile attacked on the benzene ring. What will happen? This benzene ring having the positive charge, because as the nucleophile attack, what will happen? This electrophile is attached with the benzene ring, and this positive charge occur here and this time. Okay, so what will happen? This pi bond will dissociate and this electrophile is attached with the carbon. Where some students are getting confusion, then where this hydrogen occur. This hydrogen is already present, my dear students. This hydrogen is already present on the benzene ring, but generally we are not showing this. We are not showing this. This is the complete benzene ring, CH, 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 and alternatively double bond. So, my dear students, these double bonds and these hydrogens are already present in the benzene ring, but generally we are not showing. But when we are drawing like this, we are not showing the hydrogen. But when the electrophile is generated, electrophile is attaching, this hydrogen is just showing so that you can understood that where the electrophile is attached and why the positive charge comes into the ring. Okay, now this electrophile, now this hydrogen and the electrophile is attached on the proper places, on the proper site, and this positive charge will rotate. Okay, and this positive charge will rotate, and this positive charge here, this, and this positive charge comes on the ring here. Okay, like this. Again, look at here, this positive charge here. Okay, this bond is dissociated and the hydrogen, this bond is dissociated and the positive charge comes on the ring, and this positive charge will jump as this double bond will move towards, shift towards it. Okay, when this double bond is shift towards it, like this condition occur, and when this happen, this double bond shift here and the positive charge will move towards here. Okay, so like this condition, so you can see in this resonance condition, the positive charge continuously rotating on the whole ring. It means it's a kind of the resonance hybrid. This is like this, and this electrophile and the hydrogen. Okay, so it will form the sigma complex or the resonance hybrid. Why it's a resonance hybrid? It's a resonance of the positive charge and the double bond. And why it's named as a sigma complex? Look at here. It's an alternative sigma bonds and the pi bond. This is a sigma pi. Sigma pi. Like this, you can see there are alternatively sigma and pi bonds rotating on the ring. That means the complete sigma, it's known as the sigma complex. Okay. Now this, the resonance hybrid form. Now come to the third step. What happened in the third step? In the step third, this a hydrogen is just released as a proton form, and the positive charge just deleted on the ring. Okay, so what happened in the step third? That is the proton elimination. Okay, so here, my dear students, the proton is eliminated from the ring with the help of the base, because if the base come, this hydrogen easily released from the ring and the ring get relaxed. Okay, so what will happen in this? Okay, here hydrogen and this base will come, and here this complete ring and this will form. Okay, so here the complete ring, the electrophile is attached, and this is the complete electrophilic substitution occur. Okay, this is the whole electrophilic mechanism here. First is the formation of the electrophile. Second is first is the generation of electrophile. Second is the formation of sigma complex, and third is the proton elimination. Okay, here the complete elimination reaction mechanism happen. We have discussed. Now in the next video we will discuss about the next reactions like the nitration, sulphonation, and the other reactions. Okay, I hope you enjoyed my lecture. Any doubt in the kindly ask in the comment section. Otherwise, please like, share and subscribe. Thank you.